Okay, guys, hang loose for a second while I load these two PowerPoints up, and then I'll show you what's going on today. Okay, can I be heard? Oh, good, I hear my echo. I guess I can be heard. So today we're going to cover the Module 3 VLAN trunking, and the official, this Module 3 VLAN trunk is the official slideshow for this. I'm going to have preceded with a little 10 or 15 slide preview from the early curriculum that's got better graphics. And I think I'm going to use this intro to VLANs and trunks first. And then we'll go into the main stuff here. So hang loose and we'll get going here. I mentioned to you guys last time that sometimes they'll put something in a module that really is referred to something that's coming up later in a later module, and it can be confusing to the student. So I'm going to try to work around that stuff. So VLANs, hold on, I'll turn my echo down. It's too loud. It's distracting me. But in the good old days, we were stuck with hubs, and whatever floor you were located on, you had to be plugged into the hub that was closest to you. And it didn't matter if two people worked in different departments, and we couldn't isolate the traffic between them. But with the advent of hubs, were just dumb devices. They were just transistors that repeated bits. But with the advent of switches, which were smart devices, they could set up their performance advantages. They can set up it's like the difference between, I like to compare hubs to a party line in the grandma's house in the country. 8 farmers are sharing the same phone line. Only one person can talk at a time. So with a hub, only one Ethernet workstation can talk at a time. If 2 or more try to talk, we get collisions and we have to stop and start all over again. But with the Ethernet switch, they have buffer memories and they have smart logic in them. So one person can be talking to a server and another person can be pinging the fax server and stuff like that at the same time, and they get these virtual private circuits like standard private telephone lines. You can talk to someone else on the phone line. It doesn't matter if your neighbor's on the phone. It doesn't interfere with you. So with the switches, we could do this, and the additional intelligence that was in Ethernet switches allowed them to also not only isolate individual TCP/IP conversations, but also have the ability to break the rules as to what we talked last time. What's the default behavior of a switch when he gets a unknown unicast or a broadcast request? He floods it out to all the other ports. So what we can do with VLAN technology is we can break the switch into separate parts. So in the slideshow, we're going to look at a picture. We're going to break the left half of the switch into one department and the right half of the switch into the other department, and they won't even hear each other's broadcasts. So this can also give even greater performance on the network. We'll still need to put a router in there to go back and forth between the other sessions. Okay, hang loose. A couple of people will join here. I'm going to update the attendance. And as always, this session is being recorded, so you can refer back to it later for review. So he says definition is a virtual LAN that logically segments. So we were physically stuck with our old hubs. So the building I used to work in downtown Fort Worth, I was on the 26th floor for a while, and I had to plug into that hub. Later on, I was on the 38th floor. I had to plug into that hub. And even though we were in the same department and there were other people in different departments, we couldn't isolate our traffic from each other. But with the VLANs, even if people are on different floors, 2 people are working in the marketing department and one's on the 26th floor and one's on the 38th floor, we can join them together just like if they've been plugged into a single switch that's physically in one location. Because we're stuck with this 328-foot distance, this 100-meter distance that you can run an Ethernet cable without having to use repeaters back and forth. So based upon the employment function, what project you're on, what applications you're running, we can isolate people in that network. So here's a default switch, similar to our Cisco 2960 switches. You've got your let's see, am I allowed to draw here? So you've got your 24 Ethernet ports, our fast Ethernet ports. We've got our 2 gigabit Ethernet ports. And inside the switch is all the logic and the CPU and the memory, buffer memories and stuff that allows them to all talk to each other in real time, even if more than one host machine is talking at the same time. So if we do this command show VLAN on a standard switch, keeping in mind that most of these switches that ship into the real world, Cisco makes the configuration of the switch so they're all in the same broadcast domain. They can all talk to each other. They can all ping each other. They can all do ARP requests to each other, all in the same network. Because typically in a small company, the 24 fast Ethernet ports would connect to employees' desktop PCs, and maybe the 2 gigabit Ethernet ports would plug into a server. If you had more than one switch, you would probably daisy chain the 2 switches together with the gigabit ports to get better speed. So when we do this command show VLAN, we can see our fast Ethernet ports are all connected to the gigabit ports. They're all connected to each other, or they're all in the same broadcast domain. So let's plug some workstations into this default. 75% of these switches that ship into business go into what Cisco calls SMB, small, medium businesses. So no one's going to ever configure them. No one's going to ever put any passwords on them. They're just expected to be what the old, a hub, a fast hub, what we used to do with the old hubs. So we've configured some PCs here, A, B, C, and D, with some IP addresses, and they're all going to be able to hear each other. So if host A tries to ping host B or host C or host D, of course, due to the mechanism of Ethernet, before they can ping a device, they have to learn his MAC address. So if we went to A and typed the command ping B's address, the first thing would happen is A would look in his ARP cache. He would not see that IP address 10.11, so he would issue the broadcast request, which is essentially the ARP broadcast request is calling all stations. If your IP address is 192.168.10.11, I know your IP address. I don't know your physical MAC address. I need to know your physical MAC address so I can put this ping request in the Ethernet frame and send it to you physically. So he broadcasts that request to everybody on the network at that company. The one workstation B who actually has that IP address will respond and say, oh, that's my IP address. He'll send back an ARP reply, and he'll tell workstation A, oh, I have this particular MAC address. And then they'll be able to ping each other because A will be able to put his ping request as an ICMP echo request right into an Ethernet frame. He'll be able to send it to B. So hosts can communicate with each other to be able to ping. In this case, they're all on the same IP subnet. They all have the same prefix. The bolded 192.168. Every PC's got the same 192.168.10 prefix. So they can all talk to each other just fine. So they're all on the same IP subnet. There's no routers in here. If you're on different subnets, you need routers to communicate between networks. But there's no routers in this network. So all the workstations are configured to have the same /24 prefix, the 192.168.10. So they're on the same IP subnet. And they're all in the same VLAN because by default, all of the ports on the switch by default are set to be in the same VLAN. If they were configured to be in different VLANs, they wouldn't hear each other's traffic at all. So the question, can they ping each other? Well, absolutely. So the last thing says, if A did an ARP request for B, who would hear this broadcast? Well, all the workstations, all the host machines within that broadcast domain, which in this case is the entire switch, because it's all one VLAN. A VLAN is a one broadcast domain. They would all hear that. The broadcasts are generally of the nature that it needs to go to everybody because you're not sure who is going to help you out yet. So an ARP request is sent out saying, I need IP address. I know your IP address. I don't know your MAC address. I'll just send it to everybody. Whoever happens to have that IP address, in this case, host B, would respond and tell him, and he could update. Workstation A could update his knowledge, his ARP cache, as to what that MAC address is for Workstation B. The other major source of broadcast on networks is the DHCP function, which is the Dynamic Host Configuration Protocol. That's the thing that automatically assigns IP addresses to workstations, so we don't have to run around as IT guys and manually configure all these workstations. So we need that to go to everybody because the workstation turns on, he doesn't have any kind of IP address. All he knows is his own MAC address. So he sends out this frantic broadcast, please, please, calling all stations. If one of you out there is a DHCP server, please grant me an IP address and subnet mask and default gateway and so forth so I can participate on the network. And this employee who's using me can use me during the day. So that's a default configuration. Now let's look at what happens if we partition the switch into VLANs. Let's say this is a company where everybody in the blue is going to be the marketing department and everybody in the red is going to be the advertising department. So the marketing department's got their 10 employees. So they're going to attach to all these ports here. They probably have got a workgroup server. They'll plug their workgroup server into the faster gigabit port, and all the marketing employees will connect to their high-speed server. Everybody in the advertising department, they'll be in this particular VLAN, and they'll have their workgroup server, and they'll be connected there. So this is a method that we can go into and alter the defaults. By default, this switch, everything was connected, everything else. Everybody could hear everybody else's broadcasts and Ethernet frames and so forth. So we're going to logically partition this network into two subnets. Now there's no router in here yet, so they won't be able to talk to each other. Of course, in the real world, we'd set up a router to route back and forth between the .10 network and the .20 network. So we can create 2 or up to like 4,000 different VLANs on these big switches to do this. So each VLAN is a broadcast domain of its own. So if someone's plugged into port A and they send a broadcast like an ARP request, only the people in the other blue ports, that VLAN ID, let's say it's VLAN 10, only they will hear it. The people on the red ports, they won't hear nothing. They hear silence. Typically, a VLAN will correspond to a particular subnet of an IP network. Typically, we would, if it's VLAN 10, we would make the IP address of 192.168.10. something. If he's on the red VLAN, we'll make that VLAN 20. Maybe it'll be 192.168.20. something. So they're isolated from each other. We need a router to connect them together. So this VLAN partitioning takes place inside a layer 2 switch. It's as if they were 2 separate switches and they just had to be connected to a router to do stuff. Now, this is very important. The host machines that are plugged into here, they're unaware of all this VLAN black magic. So we weren't allowed to alter, one of my computer heroes, Radia Perlman, invented the Ethernet bridge, which later turned into switches. And one of her requirements given to her by her bosses, she works for Digital Equipment Corporation, was you're not allowed to do anything to the individual workstations. We can't alter them, and we can't tag their frames or do anything like that to make this bridge thing work. We have to make them learning bridges, and they'll have to forward these Ethernet frames from one part of the network to another without having to modify anything. So with VLANs, we can't modify the workstations. All the VLAN stuff takes place in the switches and the routers that provide this inter VLAN routing and connections between each other. So now we have partitioned the switch, and we take in ports 1 through 12 and their workgroup server, first gig port, have been made into VLAN 10. Hang loose, someone came in here. Okay, who's missing? Okay. And VLAN 20, the blue VLAN was our marketing department, and the red VLAN was our advertising department. So all these ports have been configured to be in VLAN 20, including their workgroup server. And all the host machines that are plugged into VLAN 10 are configured to be 192.168.10. something. All the host machines that are plugged into the red network are configured to be 192.168.20. something. So they can talk to each other just fine. All the blues can talk to each other. They can do ARP requests to each other. They can ping each other. All the reds can talk to each other. No red can talk to no blue yet. We'll have to put a router in there. So he says, who can A ping? Well, A can ping B. They're connected together like it was a single hub. C and D, he can't ping them. A and B can ping each other only. C and D can ping each other only. C cannot ping B. B cannot ping D. They're not yet, not till we put a router in there. So if it was a single network, a single VLAN, that would be no segmentation. Wait a minute here. Go back to my slideshow, sharing, share files. Okay, so let's put a router in here. So the routers, the switch has been configured to be into the red, the VLAN 10, and the red VLAN 20 and the blue VLAN 10. And we're going to stick a router in there, and we'll configure the router to route back and forth between them. Pretty easy on the router. We just have to bring the ports up and give them the host address for the default gateway for all these individual workstations. So that'll make them work with each other. Okay, let's see. So this has some benefits. We can get security. So if it's the National Security Agency or something, or the FBI or the CIA, they can partition their networks out and have their super secret spy software in an isolated network where nobody can get to it. And so it reduces the cost. We can just buy as many switches as we need for ports, and we can divide the switch into different departments. We don't have to buy extra switches for extra departments and waste a bunch of ports that aren't being used. Smaller broadcast domains, that's going to help us because we won't have so much activity, traffic on the network. Broadcast drums, we normally suppress that with something called spanning tree protocol. We'll see in a later module. We're going to get better performance, and most importantly for us IT guys, it makes it easier for us to manage the network. So by default, what do we get? Well, by default, all switches ship with all the ports assigned to the default VLAN number 1. The default VLAN number 1 is the one that all ports are assigned to, and this nonsense over here about all these extra ports and all this nonsense down here, you can disregard all that stuff. We're interested in the actual ports that are present on the switch. So 24 Ethernet ports, 2 gigabit Ethernet ports. Later on, we're going to look at a concept called trunking, and we're going to make some of these ports, instead of access ports that go to workstations, we're going to make them trunking ports that go to different switches. We don't have to waste so many wires from switch to switch. So some of these types of VLANs. See, I'm on 16. So this range of VLANs from 1 to 1005. There are probably 1 or 2 dozen is appropriate for most companies. If you're a huge corporation, you might need a few more. So 1,000 possible VLANs should be enough for almost anybody. If you need more than that, you can use some special techniques. It's not a CCNA objective, it's a CCNP objective, and you can have like 4,000 of them. Do you remember when we had to go and when we configured the switch before we started the lab? We had to make sure that we had erased the startup configuration, and we had to erase this VLAN.dat file. If any VLANs had been created on that switch and your lab didn't have that same configuration or was the default configuration, that would mess it up. And that's why you have to erase this file, VLAN.dat. So if there's no VLAN.dat in the device, it's going to have this configuration up here, the standard configuration of all 26 ports on this stuff. VLAN trunking protocol used to be a CCNA objective. It's no longer anymore. That's a CCNP now. So we don't have to worry about that. Okay, so by default, VLAN 1 is a special VLAN it's stuck. You can't rename it, you can't delete it. You can create all the other VLANs, so you can create 1,000 more VLANs, you can delete them, you can name them anything you want to. But we're stuck with VLAN 1. And there's a lot of stuff that goes on VLAN 1 that we don't want to be normally exposed to, so we're going to look at a technique. Remember when you created VLAN 99 in that last lab? We're going to make like VLAN 99 our management VLAN. And we're going to leave VLAN 1 alone. We're not going to assign it to any ports. But by default, the switches are like that. For the 3/4 of people that buy these switches, they don't want to configure them. Untagged traffic, we haven't talked about untagged traffic. We'll talk about that later when we talk about trunks. So we can create as many user VLANs as we want to. In the case I created the blue VLAN 10 for the marketing department, and I created the red VLAN 10, the red VLAN 20 for the advertising department. The management VLAN, that's our VLAN 99 that we used in the lab. Now, what about Cisco telephones? We're going to connect the telephones up. Ethernet plugs on them. They plug right into the switch, just like desktop PCs do. We're going to give a separate VLAN to the voice because we don't want the traffic from the downloads and the data transfers to interfere with the voice. So we're going to get their own VLANs, typically VLAN 100 or 150. What about when contractors or people come into your organization and they're in the lobby and they need Wi-Fi access? We can create a GIS VLAN to them that maybe doesn't have access to the internal company goodies, just maybe internet access. And one security technique is to create what's called a garbage VLAN. We're not going to route it. It's not going to connect to anything. We're going to put all the ports that are not used in that garbage VLAN. So if somebody social engineers their way into the wiring closet and plugs into an empty port, they're not connected to nothing and they're going to do any danger. Okay, let's look at this default VLAN. We haven't talked yet about tagged traffic. We're going to cover that in just a second. So workstations, host workstations have to have the standard, previously defined standard Ethernet frames. We can't add any extra stuff to them or else they would break because the workstations can't understand that. Only switches and routers can understand that. So Cisco Discovery Protocol, the virtual trunking protocol, some other protocols we'll look at later for some other stuff like Ether channel. That's all carried on the native VLAN, and by default, the native VLAN is untagged traffic. We can change it to something else if we want to, but we won't do that till later. So by default, everything is carried across VLAN 1. By default, all ports are on VLAN 1. Default VLAN, all user traffic. It's native, no encapsulation. Oh, I haven't talked about trunking and encapsulation. This is so confusing. Everything is normally going to be on VLAN 1 because out of the box, that's what's going to be like. So by default, we can't delete it. So for security, it's considered the best practice that let's just not use VLAN 1. Unless this is a switch that's going into small, medium business that will never be configured in the first place, and they just want it to be a fast hub, they'll use VLAN 1 because they're never going to configure it. But in any kind of larger enterprise where we have security rules that we have to try to increase the security of our network, we're going to avoid using VLAN 1. Some control traffic will be on there, Cisco Discovery Protocol, stuff like that. We have to leave that on there. So we're going to create additional VLANs. We're going to create the VLAN 10 for the marketing department, and we're going to create the VLAN 20 for the advertising department, and we're going to put all our traffic on these additional VLANs that we create. So here's the code here. We go into the global configuration mode. We specify VLAN 10 with the command VLAN 10. If you don't give it a name, that's optional. It'll just say it's VLAN 10. But in this case, we're giving VLAN 10 the name of HR for Human Resources. Now, that's step 1. I've created the VLAN. Step 2 is I want to assign port 2, this guy right here, plugged into port number 2. I want to assign him to be a member of the Human Resources Department. He's the HR manager. He's got to be plugged into his network. So I'll go to his port number 2. I'll say interface fast Ethernet 02. Okay, switch port mode access. This is a default because normally these switches ship into business and the ports are access ports, means standard Ethernet workstations can attach to them. So the host is attached to them, hosts are attached to them. Later on, we're going to learn a command called switch port mode trunk, which we use between switches. Okay, and then we're going to define that host machine, which is plugged into port 2, should be assigned to VLAN 10. So we do this from the command line interface, the CLI, we attach it to it. Now, as a courtesy to you, the Cisco iOS, if I had not typed this stuff here and gone straight to this command here, it would go ahead and create VLAN 10 for me. It would pop up a thing on the screen saying that, oh, you assigned this port to VLAN 10, but VLAN 10 did not exist yet. I went ahead and just made it for you. Now, beyond the scope of CCNA, you could have a special server that Cisco will say to do this stuff for you, but that's not CCNA objective. Okay, now I'm going to assign ports 1 through 10 to be to the HR department, ports VLAN 10. And normally that would be kind of cumbersome. We'd have to go back and go back here. We'd have to do these commands here over and over and over again 10 times. But there's a feature on the Cisco switches where I can specify a range of ports, and it will do everything to all 10 of those ports with just one command. So he's typed the command interface range faster than at 0, 1 through 10, and then he's done the command switch port mode access, which is access VLAN 10, and it did all those 10 ports in one chunk. So that reduces the effort of typing, as we as IT guys have to do, reduces the chance for errors, because the more stuff you have to type, the more chances you're going to fat finger it and create some error. So we'll repeat the same thing for VLAN 20. So we're going to create VLAN 20, name it sales. Then we're going to specify interface range 13 through 22, make an access port, assign the VLAN 20, and then repeat this for the gigabit Ethernet port that's up here. And we've taken care of our 2 work groups. Sales and human resources have been taken care of. Now look what happens when we type show VLAN. All the HR guys here are now assigned to VLAN 10. All the people that were in the sales department, they're in VLAN 20. Now we left some ports unused here. We'll use those later for Cisco telephones. So type show LAN. By the way, when we type show VLAN, you get a bunch of garbage at the bottom of the screen. So if you type show VLAN brief, it just shows you the stuff you're really interested in, the stuff right here. It's a little Cisco iOS Gonzo secret insider tip of the day. Now we're going to have a management VLAN. In this case, he's using VLAN 1. In our last lab, we assigned an IP address to the switch, so we could telnet into it or secure shell into it. We're going to take one VLAN switch. It's better to use something other than VLAN 1. We'll use like VLAN 99 is typically used in the Cisco Network and Academy labs. So native VLAN. Oh, IEEE 802.1Q trunk. What the heck is that? So workstations can only send and receive untagged standard Ethernet frames. And we're allowed to have, oh, I'm getting ahead of myself. So we're going to maybe change the native VLAN to another VLAN. We'll do that later. Sorry to confuse you so much. Now let's look at Cisco telephones. What do telephones require? They don't require a bunch of bandwidth, but they do require low delays of about less than 150 milliseconds. That's about 1/7 of a second. They need to be routed. They need to give some priority. So we have this concept called quality of service, or QoS, where we can take the voice traffic, which doesn't need a bunch of bandwidth, and put it at headline. And then someone's downloading a service pack for Windows. If you slow down 1/4 of a second, nobody cares. So let's put the voice traffic on a separate VLAN, maybe VLAN 100 or VLAN 110, and use that. Okay, next huge concept, trunking. In this case, I've got 1, 2, 3, 4, 5, 6, 7 VLANs I've created on the switches. That normally would require 7 wires between all the switches to carry all that separate traffic. We would run out of ports on all our switches. What if I had 200 VLANs? They don't make switches that big. I would lose all my ports just for all the different broadcast domains, all the different subnets, all the different VLANs back and forth. So instead, I'm going to co-mingle them all on this one single physical Ethernet cable that's going between switch 1 and switch 2. And so that I don't mix up all the different subnets between each other, I'm going to do a little rocket surgery on the Ethernet frames only between the switches. The host workstations that are connected to individual switches, they don't understand this. They have to have standard Ethernet. So we're going to take those Ethernet frames when they go into the switch, and we're going to add a tag to them and say, oh, this is an Ethernet that originated from VLAN 10. And then when it progresses to the second switch, it'll only come out those ports that are also assigned to VLAN 10. This is similar to the telephone company that used to have to run a separate physical twisted pair cable for every long distance phone call. And then the telephone company figured out they could put 24 voice communications on one wire. They would tag the 24 voice conversations with different numbers so they identify the different calls. And then they didn't have to dig up ditches and put so many wires between Dallas and Fort Worth along where the old Dallas-Fort Worth Turnpike used to be. So the tagging standard that we use is we're going to take the standard Ethernet frame and we're going to tag it with the VLAN ID. This is the 802.1q standard. The 802 numbers, like Ethernet, is 802.3. Wireless is 802.11. These are the IEEE engineer standards for the stuff in technology. All the newer switches for the past 20, 25 years use this standard because this is an open source thing. It's not restricted just to Cisco. Cisco used to have a thing called InterSwitch Link. Proprietary to Cisco, only worked with Cisco devices. If you only had Cisco devices in your company, that would work just fine. But the preference today is to use 802.1q, so we ain't going to use this. We're going to use 802.1q. As a matter of fact, the Cisco switches that we use, the 2960 switches, they don't support Cisco ISL. You might run into an older switch that has it, but we're going to use the newer standard. So here we got our standard Ethernet frame here, okay? The type that's sent and received by workstations only understand standard Ethernet frames. So the Ethernet frame has a destination MAC address, the 48 address of who he's talking to, his own MAC address. We have a type length field that says, oh, I'm encapsulating an IP packet, or an IPv6 packet, or a ping request. Then we have our upper layer data, like an IP packet, and then a frame check sequence at the end, which is calculated when the workstation that A sends it, he calculates his frame check sequence. And then when workstation Z receives it, he recalculates the frame check sequence to make sure that no of the bits got messed up in the trip. If the frame check sequence doesn't match, Z will reject the frame. He won't look at it because it's probably got bogus data in it. So let's take a fireman's axe and chop up our Ethernet frame and do some rocket surgery and add a tag. And this tag has got the VLAN ID in it. It's also got some priority functions, for example, voice over IP telephone stuff. You've got a priority function in there. So the tag is added by the switch. When the Ethernet frame flows from A into the switch, he adds the tagging information. This workstation A as being VLAN 10. Then as VLAN 10's information flows to the second switch, it's tagged. But workstation B will remove the tag and make it back to a standard Ethernet frame before it goes to workstation Z. Oh, nothing confusing about that. Now, we're allowed to have one native VLAN. This is a VLAN that doesn't have any tagging on it. This is for support with maybe old devices that don't understand VLANs, for devices that don't support tagging for some reason. So all trunks have to have some native VLAN. By default, that's going to be number 1. They have to be the same on both ends of the switches. So when you go and do a lab and he says, change your VLAN to native VLAN 99, and you top it on the first switch, you're going to see a bunch of error messages that pop up complaining that the native VLANs don't match. Okay, so we've, by default, here's the default here, switches are unconfigured. All ports are assigned to VLAN 1, even the wire we plug between the two switches. It's not a trunking port yet. It's a VLAN 1 access port. But when we change it to a trunking port, all the VLANs can be conveyed across all that. So with just one connection on switch A and one connection on switch B, we can share all the traffic of all the stuff that's going on in that company, the marketing department, the human resources department, the guest lobby stuff, all that stuff can be conveyed across one wire. And so we don't waste a bunch of ports on this switch and waste a bunch of ports on this switch. So that's the advantage of trunking. So now on our switches, here's the way you configure these ports here. We're going to configure ports 1 to be trunking ports instead of access ports. By default, they're access. We want to be a trunking port. We want to save wires. So we go to port FA01, and it was in VLAN 10. This removes that. Most iOS commands can be reversed by typing the no command in front of them. Then, now this command we don't have to do on our switches because the only switch encapsulation type they understand is .1Q. We can go straight to this command and say switch port mode trunk. And this is like a toggle switch. You can flip it to trunk or you can flip it to access port. Access ports go to host machines like PCs and servers and telephones. Trunk ports go between switches and they go to the routes between those switches. So this is the minimal configuration that's going to work in that case. Now when we type show VLAN, remember our HR department had ports 1 through 10. What happened to port 1? It's gone. Well, it's no longer an access port. VLAN only shows access ports. Port 1 is now a trunking port. So port 1 is no longer in VLAN 10. Now let's look at this native VLAN. In the lab, they normally say 99 instead of 200. But you enter a command that says switch port trunk native VLAN 200, and immediately you get a bunch of nasty grams from Cisco. Pow, 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 every few seconds. And they're saying, wait a minute, I'm on this one, this switch, my native VLAN's 200. On this switch, it's still 1. I'm complaining to you. Pow, 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 pow. As soon as you go to port the second switch and put the matching command on the second switch, the error messages will go away. Okay, now I need to stop sharing this, and we'll go into the official stuff, because this official stuff is just confusing because it assumes a bunch of stuff. I don't like the order, but we'll cover it. Okay, share now. Hang loose for attendance check. So this is kind of like the situation. Oops, pencil. There we go. This is the situation when I worked downtown. We were in the city center buildings, and we had our firm had 4 floors. We had 26, 36, 37, 38, and we had hubs. So we were all connected together to the same shared broadcast domain collision domain. That was back in the 90s. They didn't have switches then. But today what we do is we put a switch on one floor, and we put a switch on the second floor and the third floor. And we'll tie them all together with trunking cables. These wires here are all trunking cables. We're going to trunk back through to the switch. Then the next module will look through to the router. Next module will look through how we program the router to route back and forth between the different networks. And so here's some IT people that are present on all 3 floors. Now with the old switches that didn't have VLANs or hubs, they were stuck with that custom domain. But now, regardless of the employee's physical place, we can simply program their port they happen to be plugged into to be a member of the proper VLAN. And they'll only hear their department's traffic. They won't hear other traffic. So we have IT guys that are on 3 floors. We have HR guys that are on 3 floors. We have sales department guys that are on 3 floors. And we can maintain security and reduce broadcast traffic in those particular ones. So it gives us good segmentation. It's manageable. So we talked about the benefits of this. I can skip this. We already talked about the benefits. So VLAN 1 is a default VLAN. By default, this is what we're going to see anytime we go into a switch that has no configuration yet and type show VLAN brief. We see that all 24 Ethernet ports and both gig ports are assigned to the same broadcast domain, VLAN number 1. Okay, data VLANs. Oh, employees' desktop PCs will be data VLANs. Servers will be data VLANs. By default VLAN 1, but we're probably in any enterprise that's more than 50 people, where we're going to configure the switches. We're going to create different VLANs for that. We talked about the native VLAN. This is assigned to the trunking link so that you can choose one and only one VLAN number to be native, no tagging, and that's VLAN 1 by default. 802.1q is the IEEE protocol for adding that tagging information to the Ethernet frame. We got to modify the frame and say this is VLAN 10 or this is VLAN 20. And then when it gets to the last switch and goes back to the host workstation, He's going to remove that tagging information because host machines can understand tagging. The management VLAN, that's what we're going to use. We're going to do that line VTY 0 through 4, login, Cisco, password, Cisco, and login, and allow you to log into the switch. That's the switch virtual interface. We're overwhelming you with the initials here. That's the IP that we assign to the switch. We can interface VLAN 99, we assign an IP address, and we can ping it, we can log into it and check stuff. We sort of did that a little bit that last time. So voice VLANs, they're done by on a separate VLAN. So he's using VLAN 150 as an example of a voice VLAN. Sometimes you'll see VLAN 100. So Cisco telephones use the Cisco discovery protocol to discover what telephone number they should be. So they look at this in the case the telephone is connected to port 18 of the switch 3, and it uses Cisco discovery protocol to find out who he's supposed to talk to. And then there's a little 3-port switch built into the telephone. And because in most offices there's only one wire, there's only one plug in the wall. So we plug the telephone is plugged into the wall port, which goes to that switch. And then the PC, which used to be plugged into that wall port, is unplugged and plugged into the extra port of the telephone. And that way he can hear his VLAN and the phone can hear his VLAN. That'll work properly. So trunking, point-to-point link between switches and routers, not host machines. Host machines cannot understand the trunking encapsulation types. Only switches and routers can understand them. So this allows us to have more than one VLAN on one physical wire. We can extend the VLAN across the entire network, different floors. By default, all VLANs are supported. We can restrict that with security commands if we want to. And 802.1q is the standard for this, the open standard. This is not a Cisco proprietary thing like InterSwitch Link. This is an open standard. So if we didn't have VLANs, everybody would hear everything else. One person did an ARP request, everybody else would hear it. What is the default? Let's say this guy does a ping, and he has to do the ARP broadcast to learn the IP address. What happens to a broadcast when it flows into a switch? By default, the switch is compelled to flood it out every port. So he floods it to the top port. The top switch is compelled to flood it to the switch. The switch is compelled to flood all the other ports so that we can. We want the host machine that has that IP address to hear the broadcast, so we have to flood it everywhere. All ports that are plugged in and active will get that. So with VLANs, we can now have, in this case, we have the faculty department are using VLAN 10, and the students are using VLAN 20. So the faculty VLAN 10, that corresponds to the third octet of the IP address, VLAN 10, 172.17.10. Student VLAN 20, he's .20 for his third octet. That makes it easier to manage later when you look at the stuff if you make that sort of line up. The wires between the switches are not access ports, they're trunking ports. All the traffic is tagged between them. So we can simply use one port on each switch and one wire between each port, and we don't have to waste so many ports for our different VLANs. So when PC1 sends out a layer 2 broadcast, who hears it? Only other workstations that are also configured to be on VLAN 10. They hear it. This guy, he did not hear the broadcast. He's on a different VLAN. So this reduces broadcast traffic. We want to reduce the number of individual workstations on one broadcast domain to a reasonable number. So we saw this before. We're going to take that Ethernet frame, we're going to chop it up with our fireman's axe, and we're going to insert the VLAN ID. We're going to insert the priority command if it's a voice over IP to give it high priority. Once it goes back to the original port, to the access port to that second device he's talking to, he's going to take this stuff out. He's going to remove the tag, and he's going to convert it back to the original Ethernet frame that it was, so that it can be understood and received by the destination host PC. Host PCs cannot understand tagging. So tagging is done on all VLANs, except our legacy VLAN. And whenever I use the word legacy in here, you will think old, obsolete, the financial accounting department is too cheap to buy us new stuff that's any good, like a hub, for example. So here's our old hub. Hubs do not understand VLAN tagging. You must use the native VLAN for them. Okay, we talked about this inside the Cisco telephone. It's a 3-port switch. Port 1 goes to the wall connection, back to the switch in the wiring closet. Port 3 goes to the desktop PC that we unplugged from the wall port. And then the second port goes into the chip, the application-specific integrated circuit, the custom chip that's in the phone, so you can process the voice conversion between your acoustic voice into packets and packets back to the acoustic voice of who you're talking to. Don't get worried about that, guys. The configuration of Cisco phones is not a CCNA objective. It's just a concept thing. Okay, when we use that command show VLAN, and it showed us that it was missing port 1. Remember that? Because port 1 had been made to be a trunk. How do I see the trunking ports? Well, let's say in this case that port 18 was in our lab. When we do port 18, we're going to type. We can type show interface of switch port. It'll tell us that, oh, port 18 is in VLAN 20. And by the way, the telephone's in VLAN 150 on that particular wire. They're sharing the wire. Okay, normal range of VLANs. And in all the Cisco Academy labs, we tend to use VLANs 10, 20, 30, and 99, about 4 of them. So we have 2960 Cisco switches. Our wiring closet has got the 3000 series switches because they have higher port density. 4,000 VLANs, that's more than what we need. In case 1,000 is not enough, if you're let's say, an internet service provider or managed hosting provider or something, you might want to use 4,000 ports. You might have lots of customers. You don't want their traffic to conflict or be seen by other customers. So when we use our standard stuff here, that VLAN.dat file, that's where it stores the VLAN definition, port 10, VLAN 10, VLAN 20. If you're extended range, it's stored in the running configuration. We will not going to do any of this stuff. This is not a CCNA objective. Don't worry about this. Okay, so I want to create a VLAN. We saw this earlier. I'm going to go into configure terminal mode. I'm going to say VLAN 10. Name human resources. And then I can go to the individual port and configure it to be in the switch. So if the student PC, there's a student PC here, he's going to be in VLAN 20. He's going to go and create the VLAN and name it students. That's part A. And what do we got to do next? We're going to configure that port number to be in VLAN 20. So we go in the global configuration mode, say interface, port 18, whatever it was, switch port mode access to make sure it's stuck in that mode, and then switch port access VLAN 20. And that will define it to be in VLAN 20. We can always change it later. If an employee moves, we can fix it. So he's plugged into, the student's plugged into port 18. We say configure terminal, interface F18, switch port mode access, switch port access VLAN 20, and we're done configuring this. We talked about the voice stuff. I can skip this. Okay, show VLAN gives us all that stuff. Show VLAN brief. I like that command because you don't get all that extra stuff at the end. So show VLAN brief is my favorite command. So here's show VLAN brief, and it skips all that stuff that's at the end. And then we can verify more detail about that particular port 18 by showing that particular command, show interfaces switch port. Now, maybe I want to delete a VLAN. Most iOS commands can be reversed by simply putting the no in front of it. Let's say I accidentally created VLAN 30, and I want to get rid of it. So I'll say no VLAN 30 at the global configuration command. Now, warning, Will Robinson. If you delete a VLAN and there were ports assigned to that VLAN, see this next one here? If I fail to move all the ports over to the new VLAN it should be in, because I'm going to delete the old one, those ports go into a limbo no man's land. So if port 1 of the switch was assigned to VLAN 30, I delete VLAN 30. What's the status on port number 1 now? The light's on, it's green. He can't talk to anybody. He has no connectivity. If I want to delete all the VLANs, we do what we do at the beginning before we do a lab. Delete VLAN.dat, press enter 3 times, and then reload the switch. So if I want to restore factory default configuration, erase the startup configuration file, delete the VLAN file, then type the reload command and reload the device. Now, due to something called VTP, sorry, I meant to accent this, due to something called VLAN trunking protocol, if a switch is plugged in another switch that has a configuration, he might try to update that switch when you do it. So they say as an extra configuration, unplug the cables. Shouldn't be a problem in our labs because we just have switch 1 connected to switch 2. We're going to erase both of them. Okay, so here's our trunking commands. We want a wire in a port to go to another switch. Generally speaking, switch ports that go to a desktop PC are access ports, standard Ethernet. Switch ports that go, port numbers that go to another switch to switch point-to-point configurations are going to be configured to be a trunking port if we're using different VLANs so that we can save wires and save ports. So we'll go to the global configuration mode. We'll say interface number. In our labs, we're going to use FA01. We'll say switchport mode trunk. We'll make whichever VLAN ID if we want to change it. And if we want to do some security commands and only allow certain VLANs, we can use that command. So in this example, we got faculty VLAN 10, students VLAN 30, and the guest lobby students VLAN 20, guest is VLAN 30. Each of these individual PCs has their own ports in the switch, and then we're going to another switch. So of course we're going to use a trunking configuration, tagged frames between the switches. So we go to port number 1 on switch 1 here, and we'll say interface fast Ethernet 01, switchport mode trunk. The native VLAN 99 is going to be our management VLAN, and we're going to allow all the VLANs, 10, 20, 30, 99. Now, if you don't type this command, everything's allowed. If you want to restrict it, you can use this command as optional. If you want to enforce security, you can use that. Okay, so that port 1, we said switchport mode trunk, and the native VLAN 99 was defined to be not 99. That took it away. We said no, that took it away because we did previously. So when we do show interfaces on that port 1, we can see that it is trunking. It's not an access port. So it's trunking administratively, it's functioning, default 802.1q encapsulation, native VLAN set to 99, and all VLANs will use that one wire, that one port F1 to pass traffic to their neighbor switches. Okay, I want to restore the default trunk settings with the no command. So we can say, you can always reverse an IOS command by putting no in front of it. If we want to put it back to the default, we can do that. Of course, you can erase a switch and reboot it, but in a production environment, you probably can't do that. Okay, I want to take the port number 1, and it was being used as a trunking port, and I now need to steal it and plug it into the new vice president of marketing. And that's the only port available on the switch. So I go in the configuration mode, specify port 1, and instead of it being switchport mode trunk, now it's switchport mode access. Now when we do this command show interface of switchport, it's access. That's going to go to the vice president's, new vice president of marketing's PC. So you can switch back and forth between them. Okay, dynamic trunking protocol is a proprietary Cisco thing. On our switches, it's on by default. This is a mechanism that when you plug a wire between one switch port to a second switch port, 99% of the time you want it to be a trunking port. Gosh, I had to type all those commands, switchport mode trunk. This can reduce the number of commands you have to type in. So if I type on our switches, on our 2960 switches, if I type switchport mode trunk on the switch 1 and I go to switch 2, it'll already trunk to the first one automatically. So here's the 4 possibilities here. If the switch is an access port, that means it's not trunking, it's not going to another switch. It's going to a host machine, like a desktop client machine or a server machine. Our switches are dynamic auto. Our 2960 switches are dynamic auto. If I go to the neighboring switch port and set it to trunking, this switch will automatically become a trunk. This is the default configuration right now for all Cisco switches. The old way that Cisco used to do it was dynamic desirable. If I plug two switches together and I didn't even go to the first switch and make it a trunking port, they would automatically trunk up, because did not God intend a wire between switch A and switch B to trunk up 99% of the time? Well, Cisco decided about 15 years ago that was a little bit too aggressive. So they went from desirable to auto, which is a sort of a man-in-the-middle thing. Now, if I wanted to do it manually, explicitly myself, I'll just say switch port mode trunk. I'll type the command in myself. So when you do a lab where you trunk two switches together, you're going to have to do switch port mode trunk on at least one switch. And they'll trunk up when you do that because they're dynamic auto. Nothing confusing about that, huh? So on our switches are dynamic auto. If it's an access port on the other side, it'll stay access port. If the switch on the other side is dynamic auto, if I trunk up switch one and the other one is dynamic auto, they're going to become a trunk. If I do no configuration whatsoever, if they're both dynamic desirable, dynamic auto, it stays an access port. The previous method was if they were both dynamic desirable, they would trunk up automatically. So on our old 2950 switches, we don't use them anymore. If you plug the wire between port of one switch and another switch, it would trunk right up. You can change this. Now you can go to our switches and you can change it from auto to desirable. If you want that, you can configure that. They just didn't make that the default anymore. So we can type show DDP interface F01 and show that. Oh, dear me, I need to stop this and go and share, because I want to show on the packet tracer a couple of commands. So I'm going to share an entire screen, and it's going to be this screen right here. You going to show the screen for me? Oh, there we go. I thought I was showing the wrong screen. Okay, so here we have packet tracer running. Oh, let me put away this screen here. So here we have PCA and PCB, and these switches have no configuration. So with unconfigured switches, okay, here's a small business, and this switch is in this wiring closet, and this switch is in this wiring closet. And can I ping from PCA to PCB? Yeah, I should be able to. So PCA, his IP address is 192.168.1.11. Should I be able to ping 192.168.1.12, this other PC here? Second one? Should I? Yes, I can, sure. And if I go to port B, can he ping his 11 neighbor? Oh, yes, of course he can. But the wires between, oh, you can't, wait a minute. Where's my thing here? You can barely see. There we go. You can barely, this mouse action is really flaky on Blackboard. So switches A and B, switches S1 and S2 are connected to each other, but through access ports. So let's go to those. Let me put away the console and bring up the console for PCA and bring up the console for PCB. I'm sorry, wrong one. I want the console for the switches. So here's a CLI for switch 1. Here's a CLI for switch 2. I'm going to move them over so we can see both of them at the same time. I want the CLI. There we go. So there's no configuration here. Let me just do just so we don't confuse, I'll go to the privilege exec mode. I'll go for configure terminal, and I'll say host name is S1, and the prop is S1. And I'll go to switch 2, I'll go to the privilege exec mode, I'll go to the global configuration mode, and I'll say host name is S2, and now we know who's who. So let's see, expand this a little bit because it's going to be hard to see. So here we are on switch 1, and if I do the command show show VLAN brief, I'm going to expand that a little bit because it's hard to read. There we go. So all of the ports, my mouse action on Blackboard is bad here. All the ports by default are assigned, ports 1 through 24 are assigned to VLAN 1. And gigabit ports are assigned to VLAN gig 1 and 2. So port 1 is VLAN 1. All the host machines are VLAN 1, so they're actively communicating with each other. If I wanted to make more VLANs on the switch, though, I should make these guys trucking ports first. So in the lab, we use port 1 from switch to switch, and we make that a trucking port. So I'll go to the global configuration mode, and I'll say interface fast Ethernet 0/1. And then I'll say switch port mode trunk. And then I'll go to the second one, and I'm going to do that just for insurance. I shouldn't have to, but I'm going to do it just in case. I'll say interface fast Ethernet 0/1. Port mode trunk. So if I do a show VLAN brief, I'm sorry, I'm gonna not show, but show VLAN brief. One's gone. One's missing. Where'd it go? Well, it's not an access port anymore. VLAN ports are access ports. It's a trunking port now. How do I see that? Well, it wasn't in the slideshow for some reason, but show interface trunk. Here we go. There's my port 1. He's a trunking port now. His status is trunking. All the other ports are still access ports. Should see the same thing on the other one. So interface is trunking. Port 1 to port 1 is trunking. Now there's a wonderful command on the real switches we can use called show interface status. It doesn't work on the packet tracer. It quickly shows you, because on our packet tracer switches, if I want to learn which ports are access ports, I have to do show VLAN. If I want to see which ports are trunking ports, I have to type show interface trunking. If I type this command show interface status, oh, it works. It works. Oh, good. It probably didn't work on packet tracer. Let's bring it over here so it's big. I like this command, show interface status, because it shows us that which wires are trunking ports and which wires are access ports. He's having an error there because let's try this, show interface status. It tells us that port 1 is a trunking port. It's not for some reason because it's a bug in packet tracer. On a real switch, it would tell us that port 1 is a trunking port, not VLAN assigned 1. He's not assigned to VLAN 1 anymore. Okay, so let's see. Now I'm going to go to, oops, ghost to mouse on the screen. Go back to Blackboard. Unshare this. Share a Brave tab. Latency, here we go. Okay, so let's see, student lab printouts, mouse action here, hardly any mouse action. Here we go. Okay, so when we come in on Thursday, we're gonna do this, I'm trying to shadow this lab right here. 3.4.6, configure VLANs and trunking, where we're gonna have basically this setup that's very similar to the packet tracer that I showed you. PCA, PCB, switch 1 and switch 2 will be connected to each other, and you'll be able to progress with that lab. So our machines in the lab do have the capability of running 2 VMware PCs at the same time. They'll be PCA and PCB. That's what they've been named. And then will be able to run the TerraTerm program on your one single desktop PC you're sitting at. And your COM1 will go to switch 1, and your COM3, we can't use COM2, we'll go to the second PC, and I'll have those pre-wired for you before you guys come in on Thursday, where you can do that stuff. So that's what we're requested to do. That. Oh, and before we do the lab on Thursday, I'm gonna pop up the display of the Cisco Network and Academy thing and show you. It's kind of confusing since they came up with the 7.0 stuff. Where is the ebook? It used to be real easy to see, but they've changed it a little bit. So I'll show you how to click into the online ebook, the textbook for this particular course, the free book we give you with Cisco Network Academy, and then I'm going to show you how you find the test to take. There used to be one separate test for every chapter, but now there's one test for they'll group 4 or 5 chapters together with. Okay, hang on just 1 second. Okay, so I think I've covered everything I needed to cover for today. Thank you for, this is being recorded for later if you want to review this later. So I'm gonna sign off now and hang loose for a couple seconds, and then we'll see you guys Thursday at 9 o'clock in the lab, and we'll do this physical lab. Thanks, and see you guys soon.